Okay, hi guys. Last podcast of chapter 2. Actually, I should probably write down that up here. My apologies. If my writing's off, actually it should be a little bit better this time because I'm back to using the Smart Slate. I'm having a couple of pen issues, so I will, forgive me now. Anyway, composition of functions, as we talked about probably in class right before we went through this, composition of functions is when you're combining two different functions together. You're actually physically picking one up, plugging it into the other one for the variable, and then simplifying it from that. As I say up here on the screen, it looks like you're plugging one function into another because you are. The reason why you're doing this is that you're trying to simplify things. You're trying to take two ideas and turning them into one. So it's your idea here is trying to eliminate a process. Okay, so we're turning two processes into, wow, this is bad. Turning, at least it will slow me down. Processes. Now you can do it with all sorts of different functions. We're going to, at least the first example I'm going to give you is going to be a linear one, and go from there. Now, I'm not covering everything. Some of the ones, the simpler ones, where you're just adding two functions together, subtracting two functions together, or, to merge the two together, are covered in your book, and the examples are very good, plus it's very basic, so I'm just doing the more involved version here, so you've been warned. Two different types of notation that are going through here. Some books, which I believe yours uses this little dot here, open circle, for composition of functions. It's the same thing as other books say of g of f of x, and that's actually how you say it. It's pronounced g of f of x. Okay, hello, come on. So what we're actually literally doing is that we are literally taking x, plugging it into f, and we're taking all of that, whatever that answer turns out to be, and plugging it into g. So before we get too far along, as an example, like right here, let's say if I asked you for f of g of 3. Okay, so what is the value of g of 3? That is equal to 3 times 3 minus 1. So that would equal 9 minus 1. So g of 3 is going to equal 8. So what's actually then ending up happening is that this g of 3 up here is going to have the same value as f of 8. Why? Because this g of 3 you just figured out is actually an 8. And so then from there, then we'll take that and plug it into, excuse me for a second, give myself some room. Next time I'll just pause. My apologies right now. So then what we'll end up doing is we're going to actually take, so then f of 8 is going to equal 8 times 8 plus 12. So then you get 64 plus 12. And so f of 8 is really equal to 76, which means that f of g, oops, f of g of 8 is equal to 76. Okay, so you're running through one process and running through another. If you remember the idea of function machines from Algebra 1, where you're plugging a number in and it's doing a process and putting a different product out. It's the same idea, except that you're doing it through two processes, much like the video that we have or you will see in class, where it's one of those how it's made videos. So that's the general sense. You probably will have to do some of those. Now, what we're about to do, you were asked actually a couple of weeks ago on a reality check. So if I asked you for f of g of x, what you would end up doing is that we're essentially taking x and plugging into g. When I plug x into g, that's 3x minus 1. I am then going to be taking this Okay, since this right here is going in the place of this x, that means that all of this is going to go in the place where that x is. And so this is going to end up equaling 8. And then instead of x, I'm going to plug in g of x. So 3x minus 1, and then minus 1. And then you simplify this, and that's it. Okay, so there's going to be a lot of chances to kind of go back, review a lot of stuff from early in the year. And so here, this is going to end up equaling 24x minus 8 minus 1. And so last but not least, f of g of x is going to equal 24x minus 9. Okay. Now the interesting thing, which I think makes common sense, but people sometimes have a harder issue with, is that they're not necessarily mutually exclusive. So we can run this backwards if we wanted to. So let's say if I asked you for g of f of x. Okay, now remember, that's the same thing, by the way, of g dot f of x. So you may see either in your book on tests, on ACTs, things like that. So again, I'm taking f of x, I'm plugging it in for g. So in this case, what I would be doing is the opposite. I'm taking this f of x, putting it in here for x, which means that I'm going to take this function, which is f of x, and I'm plugging it in right there to x. So this then is going to end up equaling 3 times 8x plus 12, and then minus 1. Ooh, you know what? Somebody should have said something. This is supposed to be a plus 12 over here. So, this should have been plus 12, and this is plus 4. So anyway, so then it's plugged in, you simplify it, and away you go. So I get 24x plus 36 minus 1. So then that's going to turn into 24x plus 35. And pending any mistakes that I made there, that should be correct. And that's it. Now, the easier ones are going to be like those which are all linear. You can also deal with stuff like this. And so I know rational functions, boo hiss. You know, all of the rules that you have done all year are still going to come into play. Period, done, end of story. So for example, if I ask you to solve out or simplify and find, and I'll use some of your notation here, let's say g of f of x. And that's not an O, it's not gof x, it's g of x, or g of f of x. Okay, again, f is being plugged into g, so you're going to write down think, if I could write. So you're going to think g of f. So x is being plugged into f, which is being plugged into g. So that means that this is going right there. So that means that g of f of x really is going to be 3. And in the place of the x, I'm going to have the square root of x plus 6. Big question, am I done? Of course not, because when teachers ask if you're done, you're never done. We need to rationalize this, no radicals in the denominator. So then we'll just go through, multiply this by root 6, or root x minus 6 over root x minus 6. This isn't as precise as I remember it being. So then on the top, you're going to get 3 root 6, or give me 3 root x minus 18 over x minus 36. And that is your finished product of g of f of x. Okay? We've got a couple days to do this. This is going to be one of those instances where you need to get your feet wet. You're going to work through some stuff. You're going to struggle with some stuff. We're going to go through some homework, and then we're going to go back and try it again, which is going to be one of the benefits of doing this stuff in class instead of trying to struggle with this stuff at home. So, again, as always, call me if you need help. Text me. Ask good questions in class. Use your class time well, and then we will go from there. So, as always, talk to you later.